right, so this is your review video for activities 31 through 33. So second half of Unit 5, really. Let me get my different colors up here. So the first question I actually did want to look at, even though I didn't write it down, which is number 3 because it asks you to determine the zeros from a graph. So I just wanted to talk about this to make sure we remembered the definition of zeros. So zeros are the x coordinates of the x-intercepts. So in this case, that would be 1 and 3. So when you list them, like I did on the answer sheet, you do not write ordered pairs. Zeros, you write x equals. So x equals 1, x equals 3 would be those answers. All right, the next whole group, I assigned you a lot of them because some of you are still somewhat weak on your factoring skills, and it's really super important that you can factor because that's one of the major ways that we solve quadratic equations. Just a reminder that if you still feel like you need additional instruction on factoring, like a reminder of how to factor, you can go back on my YouTube channel and watch the factoring review because I go through all the methods of factoring on there. Here I just picked a couple of the ones that I assigned to solve, and I won't explain the factoring part in quite as much detail. But if you feel like you need additional instruction, you can go to that factoring review and watch it. Okay, so solving by factoring. So first it has to be equal to 0, which number 7 already is. So now I factor. There is no GCF. It is a special product. It is a difference of squares. So I don't know why my color isn't changing here. Interesting. Anyway, it's a difference of squares, so that means that we've got two separate parentheses. Square root of the front goes in the front, so that's x. Square root of the back goes in the back, which would be 5. One of the parentheses gets a plus, and one of them gets a minus. Make sure that you did what the question asked, because this says to solve by factoring. So if you solved by square roots, it gets marked wrong because you didn't follow the directions. The answer might be right, but the directions asked you to solve by factoring. So once it's factored, then we use the zero product property. So we set each parenthesis equal to 0 on its own, and then we solve those. So subtract 5 here, that gives us x equals -5, and then add 5 over here, which gives us x equals 5. So those are our two solutions there. Number 10, already equal to 0, so that's the first thing I need when I'm factoring, so that's good. Next, I look for a GCF, which there isn't one. This can't be a special product because this is a minus sign, and it has to be a plus to be a PST. So next I'm going to look to see if I can chart factor it because this is a plain x squared. So I'm looking to see if I can find anything that multiplies to -100 and adds to 99. Hopefully that one's pretty obvious. We're going to use the 100 and -1. Those multiply to -100. They add to 99. So that means my factorization, two parentheses, x goes in the front of both of them, and then my winning numbers go in the back. So a positive 100 and a -1. Then just like in number 7, set each of those parentheses equal to 0 and solve. So subtract 100 here, x equals -100, and then add 1 over here to get your x equals 1. All right, number 11, I picked this one because we've had this several times, but some of you keep forgetting this. When your quadratic term is negative, you need to factor out a GCF that is negative. It might just be -1, and if it is, that's fine, but you need to factor out the negative at the very least. So here, I'm going to factor out -1 because they don't have another common factor. So that gives me 0 equals -1 times x squared. And then that would become a plus 4x and a minus 32. Now, we won't write the 1 in a final answer, but just as I was factoring it, remember that if I distribute it back, it should give me back the original. So if it doesn't, you didn't do it right. So now that I've got the negative factored out, I need to look at how I can factor what remains. So x squared plus 4x minus 32, I already know there isn't a GCF left. It's not a special product because 32 is negative and it's not a perfect square. So that means I'm going to look to chart factors. So I want it to multiply to -32 and add to 4. So the winning numbers here would be +8, -4. Those add to 4 and they multiply to -32. So my factorization, one parenthesis is x plus 8, the other is x minus 4. And then I'm going to set each parenthesis equal to 0. So x plus 8 equals 0, x minus 4 equals 0. So I get x equals -8 and x equals +4. Number 16, these are the working backward ones. Some of you tried to just give me an answer here. There has to be work for this. If they tell you the zeros, that means they're telling you that x equals 2 and x equals 9 are solutions. Our next step is to write these as factors, which means I need to get it equal to 0. So here I would subtract 2, which gives me x minus 2 equals 0. Here I would subtract 9, so x minus 9 equals 0, which means that x minus 2 is a factor and x minus 9 is a factor. So my equation I would get from x minus 2 times x minus 9. So now, to write it in standard form, all I need to do is FOIL or box multiply, whichever you prefer. So x times x gives me x squared. My outsides, that gives me -9x. Inside terms give me -2x. And my last terms give me a +18. So when I combine the like terms in the middle, I get my final answer of y equals x squared minus 11x plus 18. Number 17, it tells you that the zeros are x equals -4 and x equals 6, and this time it asks you for the x coordinate of the vertex. So we learned to find the x coordinate of the vertex two different ways. One of them was to take the x coordinates of the x-intercepts and average them. So zeros are x coordinates of x-intercepts. So the easiest way to do this is to take those two values and add them together and divide by 2. So -4 plus 6 is 2. 2 divided by 2 is 1. So that is the x coordinate of the vertex. Number 18 gives you an equation and asks you to find the vertex. So not just the x coordinate, but the entire vertex. So I could find it the same way as I did here, but that would mean that I would have to factor and solve or solve with some other way. Probably the fastest way to find the vertex here is to use our little tiny formula, which is opposite of b over 2a. So the opposite of 8 would be -8 over 2 times a, which is 1. So that gives me -8 over 2, which is -4. That's the x coordinate. Remember, whenever I need to find a y coordinate, I just plug the x coordinate in. So y is going to equal, instead of x, I'm going to put in -4. So -4 squared plus 8 times -4 plus 15. So -4 squared is 16. 8 times -4 is -32, and then plus 15. So 16 minus 32 is -16. -16 plus 15 is -1. So now this one did say what's the vertex. So this one does need to be in ordered pair format. -4, -1 is our vertex. All right, so those are the problems I picked out for activity 31. Activity 32 was focused on solving quadratics via our other methods. So starting with square roots. So we already reviewed solving by factoring. Now we're going to look at solving by square roots here in number 2. So my first step when I'm solving by square roots is to get the squared term alone. So this is my squared term. So I need to subtract 2 first to get it by itself. So that gives me x minus 5 squared equals 11 minus 2 is 9. Once the squared term is alone, that's when I take the square root on both sides. So that gives me x minus 5 on the left side. On the right side, don't forget the plus or minus. Plus or minus, the square root of 9 is 3. Now I need to get x by itself, so I need to add 5. But when I do that, remember, I'm adding 5 to 2 different things. Positive 3 plus 5 is 8. Negative 3 plus 5 is 2. So hence my 2 separate answers that I listed on the review answer sheet. Remember that I wrote up on the board the typos. This was one of them because I accidentally wrote the answers for 2 and 3 instead of 1 and 2. So make sure you fixed that. Number 8 is one of the longest problems on this review. And these are the ones where it gives us a standard form equation, which is what I have here, and asks us to write it in the form y equals a times x minus h squared plus k. Remember that this is called vertex form because the vertex is at hk. So h is the x coordinate of the vertex, k is the y coordinate. So the way that we did this in class to rewrite it in this form was to complete the square. Now, completing the square in Algebra 1, we only learn how to do when a is 1. Here a is negative 1, so my first step is to divide or multiply everything by negative 1 so that my x squared is positive. Remember, if I change one of the signs, I have to change all of them. So that's my first step. Next, because I want to complete the square, I know that I need my x terms together on one side and everything else on the other side. So that means in this case I need to subtract 8 because I need to get that away from my x's. So that gives me negative y minus 8 equals x squared plus 6x. Once I have the x terms by themselves, then my next step is to add blanks on both sides. No point in adding a blank unless you're going to fill it in. So we do that by taking the value of b, which is 6, divide it by 2, and square it. b divided by 2 squared. So in this case, 6 divided by 2 is 3. 3 squared is 9. So I put those there in my blanks. Now, on the left side, I combine my like terms. On the right side, I factor this as a PST. So x plus 3 squared is the factorization of this trinomial. Now, in order to get it in this form, I need y by itself. So I'm going to subtract 1, which gives me negative y equals x plus 3 squared minus 1. And then y still isn't alone because right now it's got a negative 1 in front of it. So I need to divide everything by negative 1, which means I change all the signs again. And so I end up with y equals negative and then x plus 3 squared plus 1. Now, that's a lot of work, but I'm not done because once I have done this, then it asks a whole bunch of other questions that you had to answer. First thing is, which direction does it open? I'm not going to write all those down. I'm just going to say them because you can see them on your answer sheet. But this one opens down. The reason why is because the a value is negative. Whether it's in standard form or in vertex form, if a is negative, it opens down. The vertex, I already told you, is at HK. So in this case, H is -3 because you have to change the sign because this is a minus. And K is 1, so the vertex is at -3, 1. Then it asks for the max or min. In this case, because it opens down, I know it's a max. That max value is going to be at the y coordinate of the vertex, so that's 1. So max of 1. And then finally, it asks for the x-intercepts. We get the x-intercepts. This one I do have to do some work on. We get the x-intercepts by solving, so by setting the equation equal to 0. It doesn't matter whether you do that with the original or whether you do that with this one. It's probably easiest, since I've already got this one, to do it here. So 0 equals negative x plus 3 squared plus 1. So I subtract the 1 first. So -1 equals negative x plus 3 squared. And then divide by -1. So 1 equals plain x plus 3 squared. Then square root both sides. So plus or minus 1 equals x plus 3. And then subtract my 3. So 1 minus 3 is -2. So -2, 0 is one of my x-intercepts. -1 minus 3 is -4. So -4, 0 is my other. Okay, so I used completing the square to write this in vertex form. We also used completing the square to simply solve equations. So here, when I am solving this equation by completing the square, because that's what my directions tell me to do, first I make sure that my x's are together on one side, which they are. My constant is on the other side. So step 1 is done for me. Step 2 is to add my blanks. So I do that. In this case, the value that completes the square is the same as what was in number 8, because b is 6 again. So 6 divided by 2 squared is still 9. On the left side, factor that as a PST, which is x plus 3 squared. On the right side, -10 plus 9 is -1. Then I square root. X plus 3 on the left. On the right, plus or minus, it's negative. So remember, now that we know, when you have a negative under there, that means I've got an I. The square root of 1 is just 1, so it's plus or minus 1i, but we don't need to write the 1. Final step to solve for x is to subtract 3. The 3 and the I are not like terms, so it just stays -3 plus or minus I. I don't know why my color wheel isn't working. I'm selecting different colors, but it's still writing in black, so I'm not sure. Sorry that it's kind of all running together. I usually like to use different colors. All right, number 19, moving on to our last method, was solving by the quadratic formula. So in order to use the quadratic formula, it has to be equal to 0. So I need to subtract the 2x and subtract the 4. So I get x squared minus 2x minus 4 equals 0. Next, once it's in standard form, I identify A, B, and C. In this case, A is 1, B is -2, and C is -4. Kind of separate out that problem. Now I sing my little song. So the opposite of B is 2 plus or minus the square root of b squared, which is 4, minus 4 times a, which is 1, times c, which is -4, all over 2a. I've said this so many times in class, but some of you are still doing this. You have to make this fraction bar, the division symbol, go all the way across. Some of you are only putting it under the square root part. This 2 plus or minus needs the division bar underneath it too. All right, so now I simplify multiplication next. So -4 times 1 is -4, times -4 is +16. On the bottom, 2 times 1 is 2. So now I do the addition here. So I've got 2 plus or minus radical 20 over 2. After I do the addition or subtraction, next is to simplify the radical. So 20 is not prime, which means that I need to try to break it down into prime factors. So it's 4 times 5. 4 is 2 times 2. So I get a 2 that gets to come out to go to the matching outfit party. 5 doesn't have anyone wearing a matching outfit, so it has to stay. So I get 2 plus or minus 2 radical 5 over 2. All right, so next I need to reduce. So 2 divided by 2 is 1. 2 divided by 2 over here, still 1. So I end up with 1 plus or minus radical 5. And I did miss telling you about this typo in class. So on the answer sheet, I typed a negative. It says -1 plus or minus radical 5, but it's not negative. It's definitely positive. So 1 plus or minus radical 5 is the correct answer there. All right, 22. The directions here ask you to find the discriminant and then list the number of solutions. So remember the discriminant is b squared minus 4ac. So b is 3, so b squared is 9, minus 4 times a, which is 1, times c, which is 5. So this gives me -20, so 9 minus 20, which is -11. So -11 is the discriminant. Then I need to use it to list the number of real solutions. Remember, the rules are, if the discriminant is positive, there are 2 real solutions. If the discriminant is 0, there's 1 real solution. And if the discriminant is negative, there are no real solutions. So that's why that is the answer here, because my discriminant is negative. Last thing, I already simplified one when I was solving. We had an I, in this answer. There's another one that has I in the answer in number 32. But these ones are just simplifying the radicals themselves. And I forgot to put the minus under there. So the square root of -144. Because of the negative, I know it gets an I. 144 is a perfect square. That's 12. So I get 12 minus 12i. Now that actually is the answer. Don't try to combine these. These aren't like terms. One has an I and one doesn't. So it just stays 12 minus 12i. In 31, I take the negative out by bringing out an I. So I've got I radical 32. 32 is not a perfect square like 144 was. So if it simplifies, I'm going to have to do work for it. So 32, if I break it down, is 8 times 4. 4, of course, is 2 times 2. This is 4 times 2 and 2 times 2. So these guys can go to the matching outfit party. These guys can go to the matching outfit party. This 2 is stuck inside, so I know I'm going to have a 2 on the inside. On the outside, I had 2 2's that got to come out, so 2 times 2 is 4. So it's plus or minus 4i radical 2. Don't put this. This is not right. In our lesson, we said that imaginary unit should always come after an integer, so 4 is an integer, but before a radical, so before the radical 2. So plus or minus 4i radical 2 is your answer there. All right, I think that covers all of the different concepts from activity 32. Now the last one, activity 33. These are the ones where we were dealing with the real life applications. So This is in our graphing calculator for the most part. If I look at activity 33 start, it starts with number 1 where they give you the data table. And the first thing it asks is the data linear, and asks you to justify it. So obviously you can see the answer that I gave. No, it's not linear. There isn't a constant rate of change. We know that because you can calculate it. Also, it's going up and then it starts to come back down. So it can't have a constant rate of change if it changes direction. So that's why the answer to number 1. Number 2 is where we have to start using our calculator, and we have to put this data into our calculator. So just walking through the steps here in case you had trouble with it. First, you got to make sure your plot's on. You can see mine is from my y equals screen, but you can go to second y equals, and it says plot is on. It says it's using list 1 and list 2. Remember, if you need to edit it, you just press enter on top of that, and then you can change it. The direction sheet that I gave you walks you through how to do that, but remember that you have to know how to do this by hand. Or not by hand, without the paper. So make sure you know what buttons to press. So now I need to enter this data. So I'm going to go to Stat, Choice 1 for Edit. And I've already got data in my calculator. I don't want it there. I need to get rid of that data and put in this new data. So the helpful hint that's on the instruction sheet says if you go to Stat Choice 4, you can clear entire lists. So I press second 1 for L1 because I want it cleared. Then I use a comma, and then second L2 because I need it cleared also. And then I press enter and it tells me done. So it cleared the list. So now if I go to Stat Edit, the lists are clear and I can enter my data. So 1 through 7 for list 1. So enter all of those and then double check them. 1, 2, 3, 4, 5, 6, 7. I'm good. So now I go over to list 2 and I'm going to enter the height data. So 144, 256, 336, 384, 400, 384 again, and 336 again. And then I double check them, make sure that it matches the data that's in the table, and I'm good. All right. So to write the quadratic function, I have to run regression on it. So I probably want to get my window ready so I can zoom stat if I want, zoom choice 9, which shows me this. I know I'm going to have to manually adjust. So it starts at 0.4. I probably want it to start out negative. It goes up to 7.6. I probably want to make sure it goes up to at least 10. So I'm going to go from -3, I don't know, to 15 maybe, counting by ones. The y's, it starts at 100. I need my height to start at 0. So because I need it to start at 0, that means I'm actually going to start a little below that. So I'm going to start at -50. And it goes up to 443 right now, and I can see it all. So I'm going to go up to 450. And then it's counting by 50s. So graph. Yep, looks like I'm going to be able to fit the entire parabola there. So we're good. So now that I've got a window, I've got my data entered, I run the regression. So I go Stat. Then I need to highlight the Calc menu, so I press the right arrow button. And then I choose choice 5 for quadratic regression. Make sure your lists are what they need to be. Remember that the instructions, if you don't get the prompt screen because you have an older graphing calculator, you can still do this. Just follow the directions by the screenshot on your instruction sheet. So list 1, list 2, and then I go down to store regression equation. Again, all this is on your instructions. I go to vars. Scroll right to yvars, choose choice 1 for function, and then I'm going to paste it in my y1. If you have the older calculator, once you have L1, L2, Y1, you can press enter. If you have this newer one, scroll down to calculate and then press enter. So now it has given me my answer. So again, I'm not writing the answer down because they're already written down on your answer sheets. But this is telling you your A, B, and C values. Remember, don't use X because it tells you to write h of t. So h of t equals negative 16t squared plus 160t. Don't write plus 0 on the end. We don't need plus zeros. So that's it. All right, so now if I go back to my graph, it should have pasted my equation in there. So now I can see the entire function, which means I can answer the questions. Number 3 asks for the reasonable domain. So reasonable domain, well, time can reasonably start at 0. So I know that one just off the top of my head. But the reasonable time to end is whenever it hits the ground. So I need to find that. So that's an x-intercept. So I go to second, trace, and I choose choice 2 because zeros are the x-coordinates of the x-intercepts. Now it says left bound, so move my cursor so that I'm just to the left of that x-intercept. Oops, too far. There we go, just to the left. So press enter to tell the calculator I did that. Puts in the nice line for me, or if you have an older model, it just gives you the triangle. Now it says right bound, so scroll so that I'm to the right of that intercept, just barely to the right there. So press enter. Puts in the other line. My intercept should be between. Then yes, I want you to guess, so I press enter a third time, and that crosses at exactly 10. So that means that my reasonable domain is t between 0 and 10, which is on your answer sheet. Next it asks, how high is it after 8 seconds? 8 is an x value or a t value, so you can get this one of 2 ways. The first way is by going second trace choice 1. We did this earlier in the year, and just pressing in x equals 8, pressing enter. 256 is the answer, so I can be done that way, 256 feet. The other way to do it would be to look in the table, so second graph, and find the y value when x is 8. All right, next one. After how many seconds does it come back to the ground? We actually already did the work for that when we found the domain, so it's 10 seconds before it's back to the ground. Number 6 asks for the maximum height. So that's up here. That's asking me to find the y coordinate of the vertex. So the maximum value of the graph. So I need to do that in my calculator. So second trace, maximum is choice 4. It says left bound again, so scroll to the left of that max. Press enter, then scroll to the right of the max. Press enter, and then press enter a third time to have it guess. And it says the max, x coordinate is 5, y coordinate is 400. So it asked for the max height, so that would be 400 feet. Number 7 asks, at what time will it be 300 feet? So I go to my y equals screen. I've already got my equation in there, don't delete it. But in addition, I'm going to type in my 300. Go back to my graph. The intersections of this horizontal line and my graph represent the answers I'm after, the times where it will be 300 feet. So I find those by second trace, choice 5, intersection points. Remember, since there are 2 of them, you have to have the cursor close to the one you want to find in order for it to work. So first curve means, is this the first equation? Tell it yes by pressing enter. Then it says, is this red one the second one? Yes, press enter again. And yes, I want it to guess. So it gives me 2.5, 300. So that means after 2.5 seconds, it will have a height of 300 feet. But it also has another answer, which I now need to find. So I repeat my steps, second trace choice 5. But this time I've moved my cursor closer to the other one. It's way back over here. And yes, the blue one is my first equation. Yes, the red one is my second. Yes, I want you to guess. And that gives me the other answer for 7.5 seconds. All right. The second set is just asking the same types of questions. So the time that the ball reaches the max, you have to do second trace max. What is the max height? Same thing. When does it hit the ground? These are all the same types of questions. So on the second set where it's 10 through 16, the only difference is that you didn't have to do regression to get the equation. Also, just as a reminder, when it asks you to do things by hand, which it does on the embedded assessment, if it asks you to find a max or a min, that's the same as asking you to find the vertex. So you can use opposite of b over 2a, or put it in vertex form, or find the x-intercepts and average them, any of those things. If it asks you to find when something hits the ground, so if it wants to know when something hits the ground, that means you plug in 0 for y, or in our case it would be for h, and solve. Because those values that you get are the zeros, which is exactly what your calculator finds for you. So you plug in 0 for y and you solve the equation. You could use the quadratic formula, you could factor, you could complete the square, all of those things. If it asks you to find when it has a specific height, so find when height equals, and then it gives you a specific value. That you can do by hand also. You just plug the value in for y and solve the equation, just like you did up here. So it's just plugging in a different value other than 0 instead. All right, so that should cover just about everything. If you need to go through calculator stuff again, you can play the part that I just did back, but please make sure you study so that you are prepared for the embedded assessment. Also, that this covers a lot of what's on the test as well.